Hello everyone, in this video we are going to see about the decision tree. Let us know first of all what is a decision tree. A decision tree looks like a flow chart representing the decision making process as rules for performing categorization. So like this, it is a condition we can categorize as true or false. Logic programming structure. In the programming concept, a decision tree is a disjunction of implications. That means we are using the if then statements. Okay, like if it condition is true, it is one branch is taken. If false, another branch is taken. Horn class defined as the disjunction of literals. Why we use the horn class term here is these implications are useful for logic programming. So horn classes are a type of logical formula we used in the logical programming. Then the key components of the decision tree are the root, the starting point, the condition, and then internal nodes are the features, and then the branches represent the outcomes. Okay, so the next slide, let us see the anatomy of a decision tree. This is the example taken for a diabetics patient case study. So BMI, the body mass index, is referred and to find the low risk, high risk or medium risk for the patient. So here the context is here. The data is based on the table which is given earlier, which has BMI, ethnicity and unhealthy status. BMI is the body mass index, and ethnicity is the group of people where they are. Like it's a one type of group of people we can represent. Okay, and then unhealthy status. So these are the data, and the flow is logic mimics human decision making based on the feature importance. So the flow is like this. If it is the greater than this value or less than this value, accordingly the cases will flow. And the logic is a split is made at BMI 25. It is greater means it determines the path to high risk. Okay, so this is the high risk path. So BMI is greater than 25 means it is unhealthy, and clearly the status is unhealthy means either it is true is the high risk and no is the medium risk, but less than 25 BMI is the low risk. Okay, so this is how the knowledge is acquired, and we are able to present the cases in the decision tree format. And then let us see how the tree is constructed. Start the root of the model, wait until all the examples are in the same class. That means you have to first prepare the data as they come under same class. Then only we can be able to split on the conditions, and then test features to determine the best split based on the cost function. So we involve a cost function over here, and accordingly it will be useful to split upon the outcome. Okay, and then follow the branch value to the outcome and repeat the step 2 means until all the classes are over, it have to repeat this, and the output is the leaf node. Thus the key concept is the central question in learning is determining which node should be placed in which position. Okay, so root versus decision. Okay, and then let us see the optimization strategy. What is optimization strategy is, once you prepare a decision tree should not go for a longer depth. Okay, so we use a concept called pruning. What is pruning is cut downing some branches of the decision tree in order to arrive the solution. Okay, that means we are just reducing the complexity of the decision tree. So now the definition of this pruning is reducing the size of a decision tree by removing the features that provide the least information. For the case we are considered, if it provides very least information, we can skip off that. That is the case here done over here, like it is given as a transparent and dotted lines, which means this tree is cut off for some reason which is not much important. Okay, and the method is typically starts from the least important feature, the bottom up. So here, from here we are going to up, and then we are going to remove the unwanted branches. So this must have started from here, and then this is not needed, so remove it. This is not needed. Like this, these two branches are removed by pruning process. So how the process goes: subtree rising, that means you are going from the subtree replacement, we are just replacing the subtree if it is not necessary, and then dimensionality reduction. This is how dimension is reduced. Okay, so result is the final classification rules are less complicated and predictive accuracy will be improved. That is the strategy, optimum strategy we use in a decision tree by pruning process. Then how to overcome the obstacle? The obstacle here is overfitting. That is the problem we have just seen before. So the scenario is if data has no inconsistencies, a tree can be constructed with 100% accuracy on training data. That means if the data are perfect, we can get 100% accuracy. Suppose the data is not perfect, it fails in the real world. Now the depth is also not set. What happens? The tree that learns the data represented. What data is given to it, it will be learning. That means the accuracy may be little less. Okay, so this is the picture showing the overfitting. So too many branches of a tree is overfitting. That only we came out with the pruning model in the previous slide. So what the solution is, set a small depth of the modeling. Random forests or jungle decision trees are useful techniques to overcome this. These two are the techniques to overcome the problem of overfitting. So overfitting is too much of information, and how to remove this using the random forest or jungle decision trees. Okay, and then let us see the key terms here in the decision tree. So we have a matrix called confusion matrix. This helps to understand the types of the correct and the incorrect predictions. So there are four possibilities. The prediction is true and it is correctly predicted, true positive. The case is negative, it is also correctly calculated, that is true negative. Suppose the case is positive but it is confirmed as false. In that case it is a false alarm. And if it is also a negative case, but again it is not correctly predicted, that is a miss. Okay, now the next case is okay, now we have seen all the terms, and how to find out the accuracy is equal to TP plus TN, means total predictions. For example, a heart disease patient is given 250 new patients are given for a model, and classified as 133 is positive case out of 150, and out of 100, 98 are negative cases. So how to calculate TP plus TN by total cases? So 133 by 90 plus 98 by 250, this is 92.4% accurate. Okay, so the context here is in many medical settings, a false negative or missing a disease is far more dangerous than a false positive. Therefore, other metrics like precision and recall are also crucial, which means that some sensitive cases we cannot stop with one particular parameter, because that may risk a patient in the case of the medical data. In that case, we have to improve the model by giving the decision tree as well as the recall. These are the two other matrices that I see in the next slides. Okay, so now the formulas are given. So we have three formulas in here. Accuracy, just we have seen over now just before. It is given as TP plus TN, that is the total positive, total negative, and then here it is all the total full thing, TP, TN, FP, FN, all the predictions. Okay, then precision, the formula is true positive by TP plus FP. That's the precision, all positives. Okay, and recall is the other one, where we have the total positive, but we have given the negative. The denominator is total positive plus false negative. This is a recall factor. Okay, so yeah, if accuracy alone may not support the model, we have to look upon the precision as well as the recall factor also. Okay, so now by the these formulas we can find out the parameters. And now algorithms, there are three algorithms. One is ID3, which is iterative dichotomizer 3. Who does the origin of the algorithm is by Ross Quinlan, and it is using the information gain as the cost function. So every algorithm has some function to involve, and here this algorithm has the cost function, which is named as information gain, based upon the some theory like father of information theory. Okay, and the key concept is the entropy. What is entropy is, it determines how impure or disorder a data set is. And then ID3 selects the node with the highest information gaining recursively. Okay, so as we know, data may be impure and data may not be ordered properly. In that case, this algorithm will have some will calculate some constant called entropy. This entropy determines how impure or how disordered the data set is, and then ID3 selects the node with the highest information gain recursively. So as we know, the tree has many nodes. The nodes with the highest information will be always chosen again and again. Okay, so limitation is ID3 is unable to cater for missing values. We have missing values concept also in the total predictions. So ID3 cannot involve the missing values. That is the drawback of this algorithm. So that means we always have 2-3 algorithms, and the mathematics behind this ID3 is it uses the entropy formula. H of s is equal to minus summation of p of x into log p of x to the base 2. This is the formula we have to learn, and where s is the set of examples and p of x is the proportion of the category x. So out of this S set of values, the probability of being category X is P of X. With that, we are using this calculating the formula entropy, and the information gain is given as Ig A of S is equal to this value H of S minus summation of P of T into H of T. Means here this is a expected loss in entropy. There may be some negative values we have seen, so that has to be removed. So the expected loss in entropy resulting from the learning the value of the attribute A. Okay, this is for one attribute. Likewise, you can go for many other attributes also. So the algorithm, when it stops when attributes are exhausted or classification is complete. So attribute means we have many properties of the algorithm. For example, if a patient, we have blood pressure, sugar, or their height, weight, their age, so all are parameters, all attributes. So they have to calculate the value based upon all the attributes or many of the attributes to get the correct result. Okay. So now the next algorithm is C4.5. It deals with an enhancement by ID3, which is done by Roscoelan himself. And now this is based upon the concept of gain ratio, which takes the number and size of the branches into account, branches of the decision tree. What is the capability is, it can handle both continuous and discrete values and improves the execution time and accuracy for large data sets. And how to optimize this introduces the bottom-up pruning, subtree raising and subtree replacement to prevent the overfitting. As we know, decision tree has the problem of overfitting. So this algorithm C4.5 that using this gain ratio concept and can handle this data. Okay, so for every algorithm we have some drawback, that is adjusted by some technique. Here it is adjusted by the bottom-up pruning. Okay. And then next is the algorithm is the CART, the classification regression trees. It is based upon the binary tree structure. We had multiple branches of the node, but here only the branches are 2 as we are using the binary tree. Okay. So what is the advantage of the algorithm is it can be used for both regression as well as the classification problems. And now we are coming under the classification problem of decision tree. It is also used for regression also, as the name implies, classification and regression tree. And the cost function we are using here is the Gini index. This is one name of the index called Gini index, which compare the entropy. Okay, so Gini is used to minimize the misclassification. How to minimize the misclassification? Compare the we do it by doing the exploratory analysis. Okay, so while entropy is used for exploratory analysis, Gini is used to minimize the misclassification. Means entropy helps to analyze the things, get the values, and Gini helps to differentiate between the expected value and the received value. That is the misclassification. We expect some result, but it doesn't come. That means it is not classified properly. That is called misclassification. And that will be minimized by using the Gini index. Okay, so that is the base of the CART, and the comparison chart is given over here. So we have 4 parameters to say: cost function, structure, pruning and missing values. The algorithms are ID3, C4.5 and CART. So here it based upon the cost function is entropy, which is information gain in ID3, and C4.5 uses the gain ratio, and CART uses the Gini index. Okay, and the structure is both ID3 and C4.5 uses the multi-branch tree, whereas CART uses only the binary tree, which has to only maximum 2 branches. And pruning is not done in ID3 but it is done in C4.5 and CART. And missing values, it is not in ID3, but it is there in C4.5 and CART. Okay, so this is a comparison between the 3 algorithms of the classifications comes under the decision tree, and that's all for the concept of decision tree. Hope it is easy and simple to follow, and thanks for watching.